Hello everyone, my name is Pawel Dudek, and today I'll take you to a journey through behavior-driven development world. But before we go into that, I would like to say huge thank you to the organizers for inviting me here and for creating this tremendous conference. I've had an amazing time here, and what I'd like you all to do now is to give a huge round of applause to them. So please. Thank you. And just a little bit about myself. I've been an iOS developer for 10 years now. Time flies. And I currently work at a company called TapTal. We're actually sponsored here, as you heard. And we're an exclusive network of top freelance talent from all over the world. We have software engineers, designers, finance experts, and our talent works for top companies all over the world. If this sounds interesting to you, we actually have a booth back in the main lobby. Brian will be more than happy to answer all your questions. And apart from that, I run a meetup, so if you're ever in Warsaw, please stop by Mobile Warsaw. We have free beer. And now, let's get into the world of behavior-driven development. In previous talk, we heard that software still sucks. And I hope that with what I'm going to show you today, you'll learn how to make it still work. But before we talk about what behavior-driven development is, I would like to talk about something much more basic. And specifically, I would like to answer a question: what is a unit test? Well, usually when I want to learn about something that I haven't heard about before or something that is new to me, I go into Google. I assume everyone here does that, right? Who uses Bing? Not a lot. Sorry, people from Microsoft. I just had to bring this up. You go to Google, or Bing, and you enter the definition or the keywords for what you want to learn about. And the first thing that usually pops up is Wikipedia. So when I was preparing this talk, I went to Google, I typed unit test, and I went to Wikipedia to read what it has to offer to me. So please take a few seconds and read what is written there. Now, if I had no prior knowledge about what unit test is, if I saw this, I would go, what? Let's take a look at this again. Modules together with associated control data, usage procedures, operating procedures. How am I supposed to apply this to writing a unit test? If I had no knowledge how to write a unit test, if I saw this, I'll be like, what? So let's try to answer this basic question: what is a unit test? But to do that, we need to answer a much more profound question, which is, what is an app? Regardless of whether it's a web app, mobile app. Well, to me, an app is a set of behaviors created by programmer and expected by the user. Of course, there are multiple other people who are involved in the process of creating a mobile app, or any app at all. We have product managers, project owners, we have QA, we have UX designers, UI designers, interaction designers, lots of people who take part in the process of creating software systems. But in the end, it is us programmers who create the code that makes up to an application. I want you to remember this. And now I'm going to say something probably very true that all of you understand, is that we humans have a limited cognition. There is only so much we can understand at a given time. And this means we can't always load all the code of our application into our minds. Because, of course, an app is a set of behaviors, but it's also hundreds of thousands of lines of code that you need to remember each time you're making a change. And this means that by accident, you can break things. Now, let's, oops, got out of sync. Perfect. Now, let's imagine a hypothetical scenario. You're working at a startup, a stealth startup. You have a new product that you're working on, and the day has finally come. It's been 2 years, and you finally shipped it. It's a huge success. People love it. People pay shit tons of money for it. You have money coming in from the users. You have investors lined up who want to invest into your application. And it's a honeymoon at your company. Everyone is super happy. And one day, one of your managers approaches you and tells you, hey, Pawel, I would like to change this little part of our application and add a couple new features. So what you do, of course, you go into your ticket system, you create a couple of tickets, and you start working on them one by one. And you pick up the first one. So you go into the class that is supposed to take care of that part of the logic. You open it and, oh, God, what is this? What sort of abomination is this? Who wrote this code? You take a look at it. Of course, it was you, but hey, you learned something through the last couple of years. And the first thing you feel is the urge to make it better, the temptation you just cannot resist. So you go ahead and you refactor that code, and now it's beautiful and you're so proud of yourself. And of course, then you wrap up all the other features that were supposed to take part of this change, and you ship out. But then, it turns out that that very, very ugly code you just refactored was handling a very nasty edge case that you didn't think about at that point, because it was 1.5 years ago that you wrote that code and you just didn't remember. Now, let's see how this can play out, because there are a couple of scenarios how this can play out. The first scenario is, well, you remembered that that edge case was handled there. But let's admit it, who would remember about this about 1.5 years ago? I know I wouldn't, and I'm pretty sure most of you wouldn't, because your memory just pushed that out. So this is not a likely scenario. Another scenario is that your QA caught that. Who has QA here? Raise your hands. Okay, it's way worse than usually. So for those of you who do not have QA, I'm sorry, please go to your company and ask them for a QA person, even half-time. For those of you who have QA, this is a likely scenario for you. So if you have a QA guy, well, of course, he will probably notice the bug. He probably runs regression tests, but know how much time gets wasted here. Because first, he needs to find that issue. Then, he needs to find a reproducible way of repeating that issue. Then, he needs to enter it in your ticket system. Then, your team needs to understand what is the problem. And then, you need to take the ticket, usually after a couple of weeks, load all the context back into your head, which also takes time, and fix the bug. All that time that you could have spent on writing new features, all that time your QA guy could be testing new things that you built, not some old existing code that should still be working. But alas, it's still a happy scenario, because this never went out to the users. What if it did? Well, obviously, people are different. Some people might not care if the app crashes, but some might be pretty pissed off, because maybe very important data was lost. And then they'll probably switch to a different product. And your company will be pissed. You will be pissed because, hey, we all want our companies to succeed. And this generally shows a problem in our industry. A problem that preserving behaviors of systems is hard. And this is regardless of whether you're building a simple or a complex system. Now, I'm going to tell you a small story. About 8 years ago, in my first company, I worked on a software for crash reporting. So pretty important part of a system that you build if you include a crash reporting tool. And each time we shipped a new update, I wasn't really sure, does it still work? Didn't I break something from the existing functionality? Does the new functionality work correctly? This fear was just horrible. I would never, ever want to go back that situation. And in fact, if this was the software development world, I would probably do something that is way less stressful, because I don't handle stress too well. But fortunately, we programmers, we like to come up with solutions to problems. So we came up with the idea of unit tests. And here we finally arrive at a, in my opinion, much friendlier definition of a unit test. To me, a unit test is a guard that stands by your code and tells you, nah, Pawel, you cannot change this. Because if you change this, this previous thing, this horrible edge case scenario will be now back in your application, and your app will crash. So again, a unit test is a failsafe to make sure your application's behavior is preserved. And now let's move one level up, and let's talk about test-driven development. As the name suggests, tests drive the way you code. But that's not only it. In fact, if you're writing tests first only, you're not actually doing test-driven development at all. Because by writing tests first, you're forced into thinking, you're forced into thinking what responsibilities your objects have in your code. And because of that, you arrive at a much more think-through design of your application's architecture. Now, if there are 2 slides that you'll remember from this presentation, please let it be the next 2 slides. Your tests are here to tell you that the design, the architecture of your application has become way too complex, because there is, okay. Assume this is the problem. Yep, technology. We skipped a few slides, and come on. Software sucks, yes.
You didn't test your slide deck after you reformatted it.
No, it's actually the presenter. It's not the first time. So I assume using my own, exactly, was not the best idea I could have had. Exactly. Tests tell you whether the design of your application has become way too complex, because there is no such thing as untestable behavior. The only thing that is not testable is your code. Now I'm going to tell you a story from the first time I showed this slide to a group of people at the meetup that I run. And I got a very, very good question from the audience, which was, okay, Pawel, if you can test everything, how would you test a random number generator? And I was like, what? Okay, yeah, but that's part of the system, so we don't test that. I basically dodged it. But then if you're building operating systems, you obviously want to have unit tests for that, so you're basically screwed. So this question kept on drilling in my head. And as I was going back home, I kept on thinking, what to do about this? And then it hit me. Is there a thing like random number generator in software systems? No, we only have pseudorandom generators. We have an algorithm that takes some data on the input, crunches it inside, and spits out some data. There is nothing simpler to test than a pseudorandom generator, because you have the algorithm, you know how it works, so you can write expected input and expected output. It's that easy. So it's usually just a matter of how you structure your code and how you think about your code. And what are the most common scenarios where your code tells you that there is, the test code tells you there is something wrong with the code that you're writing? Well, maybe you have to simulate the behavior of your dependencies, dependency. Or maybe you have to fake 7 objects to isolate the test. Or maybe you have to call 5 functions to make a test work. Or maybe you're just having a hard time defining requirements for your objects. All these problems point to an overcomplicated design of your application, and your tests are here to tell you that very, very clearly. If you're having problems writing specification here and now, then probably you in the future and any of your colleagues will have problems understanding what is the purpose of this object in the system. Moreover, by writing unit tests first, you're forced into thinking, what are the responsibilities of your objects in your code? And because of this, you can structure it better so that it's more easily testable. And because of that, you arrive at a more think-through design of your architecture. And now we arrive at, I think, the most beautiful thing of test-driven development that I just lost. The fact that by writing unit test first, you're becoming the first consumer of your upcoming API. And note what an amazing moment this is. You run your tests. There is probably no production code written at all yet. And you can already tell, okay, this API is shit. It's bad to use. I wouldn't want to use an API like this. And since there is not a single line of production code written, you can make a change at this point. You didn't write any production code yet. And your tests told you that. In fact, you might have not even written the actual tests yet. Maybe you just written the setup for the test, and you can already tell there's something wrong. Now, I would like to go back to the slide that there is no such thing as untestable code. Because surely, if there is untestable code, there's got to be something like testable code. What is testable code? Well, coincidentally, as you can all probably slightly feel already, testable code equals good architecture. And now this is the moment where I could make a nice segue into talking about good architecture, but we only have 40 minutes, and I could probably blab about this for 5 days. So I'm just going to skip this part. And what I'm going to do is ask you to watch this presentation called Solid Object-Oriented Design by Sandi Mentz from Goruko 2009. I would say that those 45 minutes by Sandi sum up all my feelings about good architecture, and I highly recommend you to watch it because it's an amazing talk that sums up all the basic foundation you need for writing good architecture in 45 minutes by applying solid principles and slightly expanding on them. But now, let's go back to the main topic of our journey, which is behavior-driven development. And how does it differ from test-driven development? Well, it's actually not that much different. In fact, I would expect that people who are very good in test-driven development actually do behavior-driven development, because this is exactly the way behavior-driven development was born. It was born out of experience of seasoned test-driven development practitioners who found TDD lacking in 3 certain aspects. And let's talk about what those aspects are. First, PDD tries to help tell you what to test. Now I'm going to tell you a slightly embarrassing story about myself. Back in the day when I was still working on that beautiful crash reporting SDK, I was very lucky to have a lot of good mentors through my entire career. And back in those days, I had a guy from Google who built Google Contacts. Who knows Google Contacts here? Quite a lot of people, so. And he was an amazing engineer. I loved working from him. But I was pretty young, and I thought, unit test, who needs that? And he kept on blabbing like, Pawel, you should write those tests. And I was, of course, ignoring. And then one day I thought, okay, he's been talking to me about this for the last half a year. Okay, next day, I'm going to try. And I actually tried to get myself excited about this. Okay, I'm going to write my first unit test in my entire life. So the next day, I rushed into the office. I ran into my desk. I sat at it. I opened my laptop. I opened Xcode, which is iOS engineer's IDE. I created a new test suite file. I put my hands on the keyboard, and then I had this void in my head because what do I do now? Like, what should I test? And I stared at the computer for about 15 minutes with nothing in my head, and then it hit me. And guess what I wrote a test for? Whether a singleton is a singleton. Awesome business value, Pawel. Yes, the app will never ever break. And of course, this shows a very common problem that I know lots of people have. That you don't know how to start. Everyone tells you, yes, this is the way to write software, because then apps won't break, you'll have better architecture, but it's hard to start. So BDD tries to make it simpler by telling you, don't think about tests. Think about behaviors. Think about examples, how your objects should behave. Think about how your objects behave, and of course, the object's behavior is defined by its public interface, and that is the only thing that you should be testing. You should not be testing internal implementation of your objects, because if you do, your tests will be more of a burden. But we'll understand why is that in a couple of slides. And of course, you should work outside in. So when you have a new feature, instead of starting off with some random object that you think you'll use in this feature, you basically think about the feature on a top level, and then you start drilling down until you find the smallest component in your system, and you test that as a black box. And last but not least, you should use Ubiquitous language for writing tests. And this is actually something really cool. The idea behind this was that so everyone on your team can easily understand what this test does. And out of this, a couple of standards were born, but most importantly, RSpec was born. Who knows what RSpec is? Not bad. I'm pretty sure that if you're doing tests in BDD, then you're probably using something RSpec inspired. Because once RSpec was born, it inspired a hell lot of other frameworks. We have frameworks for BDD style, like RSpec style in Rust, Go, JavaScript, Objective-C, Swift, Kotlin, and the list goes on. And what's amazing is that once you know the structure of RSpec, you can easily go to other code base and just read those texts. What I do very often at Toptal is I go into tests in RSpec for our platform because they're much easier for me to understand. And I just look, what can I do with this object? What can I do with this API? And if I didn't have the knowledge about how RSpec works, it will be much harder for me. But now I can just easily read and easily use that API. So it's amazing for cross-functional teams when you have back-end and front-end services in one company. And now, for the thing that you've been waiting for, so let's see some code finally, right? So let's talk about Quick and Nimble, which are BDD Swift frameworks. Actually, Quick is the DSL framework, and Nimble is the matchers framework. Who knows Swift here? Not bad. I expected less. The good news is that I think all of the languages are somewhat converging right now, so it's going to be super easy for everyone to read. Actually, when Jim from Microsoft was presenting the other day, when I looked at C#, it is really similar to Swift. And the same is with Kotlin now. So I'm pretty sure all of you will be able to read it. So let's take a look at how a simple test in Quick looks like. Do people in the back see it? I heard a very faint yes, so I expect that was a yes, hopefully. It won't get much smaller, so that's good. So let's quickly go through what is happening on this screen, because it might not be immediately obvious. Well, of course, we define a class that is called Dolphin Spec. Spec stands for specification, because you're writing specification for how your objects should behave. It, of course, inherits from Quick Spec, which is the base test class all test suites needs to inherit from. Then we override a function called spec, where we provide all the specifications. We can say, thank you, Apple, for all this Chrome that we need to add here. Maybe at one day this will be better, but so far we need to live with it. Then we define two closures, which basically are our tests. And in those closures, we basically say that we expect our dolphin to be smart, and we expect it to be friendly. What's great about this is that you get human-readable sentences. What is the actual expectation? So if your tests fail, you'll see a failure which then says, dolphin is friendly, failed, because we expected it to be truthy, but it was falsy. And what's great is that this already sets a certain thinking in your head. Well, this is a simple example, so let's complicate this a little bit by adding a describe closure. I removed the class definition on top because it's just Chrome and would take up space on the screen. So a describe closure is a thing that allows us to group similar behavior together so that it's easier for people to read afterwards. In this specific scenario, we're saying that we're testing dolphins click. And of course, on the same level as the click describe, we could have a describe that would basically say, now we're testing its sight, or maybe its eyes, or maybe its ears, and so on and so forth. So it's a very nice way of grouping your tests. For those of you who already started thinking, can I nest these indefinitely? Yes, you can. However, it would be a very bad idea because your test will become basically very hard to read. And for me, it's a very good symptom that something wrong's here. I gotta start extracting classes to make it simpler. So now, yes, the describe blocks and the actual test. And now let's take it up a little bit higher with the complexity. And here we have a before each block closure, sorry, still in Objective-C world slightly. A before each closure. And the before each closure is pretty simple as well. As the name suggests, it's something that is run before each test. So in this scenario, we'll first run the outermost before each closure, then the innermost before each closure, and then the actual test. And then for the next test, we'll run the outermost before each closure, innermost before each closure, and the actual test. Pretty simple. But it allows you to structure your tests in a much more grouped manner, so they're more categorized and easier to understand. And now, let's talk about real-world example, because all this is just, well, slightly artificial. So let's see how we can apply the concepts of behavior-driven development to real life. And we'll start by writing a class called photo upload view controller. For those of you who are terrified by the inheritance from UI view controller, which I think might be very hard to read, UI view controller is a class in iOS frameworks that basically says this is a thing that controls a part of the display on the screen, or the whole screen, should you choose to. So it basically is something that drives the UI. And here we have a UI view controller whose only responsibility at this point is when a top right button is pressed, we want to upload a photo. Currently, we don't care what the photo is, where does it come from, so we just create a photo or an UI image to be specific, and we pass it to our photo uploader, whose only responsibility is uploading photos. Pretty simple setup. We also have some setup to set up that right bar button item, where we basically have a label that says done. The target is the action that will receive the, the target is the object that will receive the action message. And that's basically everything that is happening here, nothing too much complicated. Now let's look at the photo uploader thingy. It's pretty simple as well. It's just a protocol that declares a function where you can pass in an image and a completion closure to be notified when the upload completes. And now the beauty of Swift comes out. Since it's a very statically typed language, we have no way of automatically generating mocks, so we're forced into this caveman approach where we have to write them by hand. There are some tools that allow you to automate these, but it's a side note. For the record, this is basically a mock that I wrote which flips a flag when the function is called. Pretty simple. Let's take a look at the setup of the actual test suite. Here we basically declare two objects that we have, which is our mock photo uploader and SUT. Who knows what SUT stands for? Ooh, this is going to be interesting for you. So SUT stands for System Under Test, and it's a very common way of saying in tests that this is the thing that I'm testing. And I encourage you to use it because it's going to be much more clearer for people who read your tests to understand what is happening here. So here we create our mock photo uploader, we create our system under test with it, and then of course in something that is new on this slide, in an after each block, which as the name suggests is run after each test, we do some cleaning. Pretty simple. So now let's take a look at how a very non-BDD style tests could look like. Now here we basically have a test that verifies whether our navigation bar button was set correctly. So we check whether it has the right target, because we pass that into our object, right? Then we test whether the action is correct, because, well, we pass that into its setup function. It makes total sense. And then afterwards, of course, this misses test whether it has the right title, but that's a side note. And then, of course, since we know what is the function in tests that's going to be called, we have a test for it, right? So we can directly call that function with that bar button item on our system under test, and we can verify whether it flipped the flag. Makes sense, right? This is a pretty nice test suite. There's one huge problem with it, though. If you write your tests like this, they're going to be horrible for you. Each time you go into that class and you make a slight change to the way it's implemented, you'll probably have to refactor your tests. And your tests will become more of a burden than something that liberates you. Because each time you make a simple, small change, you have to go back to your tests, refactor them. Small change, back to the test, refactor them. And this is downward spiral. Because when you start this, you'll start trusting them less and less and less. And at some point, you just stop writing them, which is pointless because your tests should be up to date. So now let's take a look how by slightly changing our thinking, we can improve this. What is the thing that we want to check here? Well, when the button is pressed, I want the photo uploader to receive a photo. So let's do exactly this. Let's simulate the behavior of tapping on the button, and then let's just verify whether that action was received by a photo uploader, because we don't care about anything else. Why should we? Now I can go inside that UI view controller subclass, and I can change whatever I want around that button. Maybe I'm crazy enough and I love reactive programming, so I'm going to pull in reactive Swift, and then I'll use signals in it, which would break the previous tests. But in this test, it doesn't matter what we use underneath. It will still test whether the right thing happens. And I encourage you to write tests this way. This is, of course, a trivial scenario, but I'm pretty sure that you have a lot of tests that could benefit from slightly changing your thinking about what you're testing, because you should never care about what happens inside. You should only care about what is the desired behavior, what is the API contract of this object. Now for the obligatory recap slide. Remember that tests influence your architecture, because there's nothing like untestable behavior. The only thing that is not testable is your code. Think behaviors, don't think tests. And of course, don't test implementation. Work outside in and test your objects as black boxes. And last but not least, use a ubiquitous language so that this will be easily understandable for all members of your team. Thank you very much. This is all I had for you. I hope you had fun. I honestly have no idea if we're out of time. Are we out of time? No, we have yes, we have a little bit of time for questions. Yes, no, yes, okay. So if there are any questions, please hit me. Of course, I'll be just somewhere around here. So if after you don't want to ask the question on the big stage, I will be happy to answer it afterwards. So any questions?
Okay, so then we go for a coffee,
Yep.
right?
Thank you again, and see you after the break.
Thank you so much, Pawel.